So hello everybody. Today I will be presenting to you the fully new current measuring power line testing device. Here is the first sample over here together with the complete test setup. So let me first show you what I will be presenting today. So the device itself looks pretty much like any other power line testing device. It's a one-phase device with a standard voltage input right here. Besides this input, there is also a current input right here, which you can see. This is what is added, and this is a coaxial cable, a standard one, together with a BNC connector. So the BNC connector is right here. So this is how the device actually looks. Next to it, there is a gender changer, which will be provided with the device. And there will be a set of non-standard broadband 1 megahertz Rogowski coils also provided together with the device. Over here, you can see two examples. So first, one example right here, which is a Rogowski coil, which has 20 amp, 200 amp, or 2000 amp ranges with three different voltage to amp ratios, 1000 millivolts per amp, 10 millivolts per amp, and 1 millivolt per amp. Now, these ratios, as you can imagine, are very important in the software, which I will be presenting slightly later. As you must always choose the correct current to or voltage to current ratio when you work with the software. So the Rogowski coil itself looks like this. You detach it and you attach some substantial current load to it. Now, since in this particular test setup we don't have a substantial current load, we will not be demonstrating with actual currents, but we will be using a voltage generator instead. So next to this standard broadband Rogowski coil, we also have a slightly modified version right here, which is a bit more sensitive and has 200 millivolts per amp, 20 millivolt per amp, and 2 millivolt per amp ranges right here with 10, 100, and 1000 amp current ranges. So every one of these Rogowski coils has a BNC connector as an output to the amplifier. And this one is then connected to the middle input of the power line tester current version. So let me now show you what kind of signal I will be inserting into the signal for the demonstration. So at first, I have set up the device to actually monitor voltages right here with a 70 kilohertz frequency, which is a sine frequency, which is inserted into the device with a 3 volt peak to peak. I will then afterwards, in the software demonstration, put this same input onto the current input of the PLT device. And let us go into the software presentation now. So I will now present the application itself as it was developed for the current version of the power line tester, the new one that I've just presented also in physical form. So here's how the application looks. I will enter the application just like I do normally. The application will come up, and please note that there is now another additional option called current monitor. Right now, what we are seeing is a signal at 70 kilohertz, which is inserted through the functional generator, and we're now actually measuring voltages. So if we go to the oscilloscope, we will see that the amplitude of this signal is exactly 1 volt, as you can see the amplitude right here. So what I will do now, I will of course demonstrate the additional features through the current monitor, and to do this I will first step to the device itself and I will connect the voltage output of the functional generator into the BNC connector. Right now it is not connected to the BNC, it is connected to the normal voltage inputs. I have now done this reconnection. I will clear the signal. Please note that in the voltage mode, this signal is now 6 decibels, meaning 1/2 smaller than it was before. However, this is accounted for in the current monitor. When I click on the current monitor option, I have a selection of ratios which I can choose from. And you can see that there are 6 of them, just like we have seen in the 2 available Rogowski coils. These are also standard ranges. Usually you have 1 millivolt to amp, 10 millivolt per amp, and 100 millivolt per amp. So let us say we will now choose 1 millivolt per amp. And please note that we are dealing with a full range now. So we are having 1 volt maximum. And now we have this screen with the pre-selected 1 millivolt per amp, which is right here. You can see from the URI up here that we can also control this by just inserting the proper value into the address line here. Please now note that the units on the y-axis are in dBAs, meaning dB amp. This is all scaled to an amp level. So here in this 1 millivolt per amp ratio, we are dealing with 60 dBA. So what does this actually mean? If we go into the oscilloscope mode now, with 1 millivolt per amp, this is actually 1000 amps. Why? Because 1 millivolt equals 1 amp, and at 1 volt, this is 1000 amps, obviously. Okay, now let us do a change, and let us go back into the voltage monitor, okay? And let us now choose, for example, 2 millivolts per amp. So by choosing 2 millivolts per amp, which is evident from the title right here, we now have a slightly smaller signal, which amounts to about 52 dBAs. If we go into the oscilloscope mode, you can see that the full range is now about 500 amps. So on the y-axis, we now have currents in amps, and as 2 millivolts equal 1 amp, 1 complete volt will equal about 500 amps. And this is actually what we are seeing in this current oscilloscope. So this is how it works. So basically you can work with either having the device in voltage mode or in current mode. So what else we have? We have also implemented the recorder, which works properly as it works in the voltage recorder. So basically it's the same. You go into onboard recording, you make a manual start, and we will make a test subfolder, let's say, with a standard recording. Okay. Please now note that also the recorder is in dBAs over here on the y-axis, and everything is properly rescaled to this new unit. So let us go back now to the current spectrum analyzer, and then let us try to view these files. Okay, please note this test folder I have just made. You can see there is our file right here, which we can play. We can just normally play it as with any other file in the voltage PLT. Run again, and let us now go back into the original voltage monitor, into the original application we have right here. And you will see there is an interesting feature we have implemented when recording. If we go into view files, you will see certain auto-generated folders over here. In this case, we don't have all 6 of them, we just have 5. And under each, there are files which we have stored. In our case, we have stored files into this test folder. Please note now that if we try to play one of these files in the voltage mode, the device will tell us that we should use the PLC current spectrum analyzer to view this file, not to make a mess out of units. Okay, we can still play files which are stored in other folders and files which are stored in the root folders, like I'm doing right now. That's okay. But for viewing files which have been stored in the current monitor, you must first go into the current monitor, select the proper mode. Let us select, let's say, 2 millivolts per amp, and we will now only see those files available for us which have been recorded in the 2 millivolt per amp mode. No other files can be seen right now. So this is how this device works right now. I think the device is very useful. It is a novel device, and I think users will find it very useful.